can hook it up as, oh, thanks, John. You can hook it up as an L, and it just depends on ear space primarily, where you have things to hook it to and stuff like that. This busy slide shows a quarter wave vertical antenna, and you don't really need to pay any attention to the details of this diagram, but you do need to know that this kind of an antenna requires a ground plane, which is a conductive surface that acts for radio purposes like a mirror. So it effectively lengthens the quarter wave vertical to a half wave. And if you're familiar with the mag mount or magnetic mount antennas that you can pop onto your car roof, those are quarter wave verticals, and the car roof is a perpendicular conductive surface that is really perfect as a ground plane. You can also have ground wires that can be in different configurations, and the general rule for that is the more ground wires, the better. And here's the meat of this slide is a formula to calculate the length of a vertical quarter wave in feet is 234, which you'll notice is half of 468, divided by the frequency in megahertz. This is a side view of the radiation pattern of a quarter wave vertical. And if you look at it from above, it's round, looks like a donut, and the axis of the antenna is running right down through the donut hole. And again, this mentions the car roof as a perfect ground. Now we're switching to a directional antenna. And the most common of these, or I guess the most common, is called the Yagi, after one of the people that invented it in Japan decades ago. And it is, as said, directional, which means that it radiates best in one direction. The way these things are made is there's a driven element, which is the one that's hooked up to the coaxial cable. It's on a boom, which is just a piece of metal that holds the other parts. And then there's a reflector, which acts like a mirror. And then there's one or more reflectors and one or more directors, which basically the director acts like a lens focusing the beam, and the reflector acts like a mirror. So that means it's got excellent gain in one particular direction. People that use Yagis have them on a rotator so that you can pick your direction. This is some other kinds of directional antennas. The beam that we just talked about, this is a quad, which is also directional, and a dish is also a directional antenna. Okay, now for some questions. Which of the following describes a simple dipole oriented parallel to the Earth's surface? And it's a horizontally polarized antenna. In which direction does a half-wave dipole antenna radiate the strongest signal? And remember, we said broadside or at right angles to the antenna. Here's one that uses that formula, and this one has a couple little tricks in it. What is the approximate length in inches of a half wavelength 6-meter dipole antenna? So this is a dipole antenna that you are setting up to work on the 6-meter band. So how do you get this? Remember that the formula is you divide 468 by the frequency in megahertz, and that gives you the wavelength in feet. So first you have to convert the wavelength to frequency, And you do that by, if you remember from yesterday or a couple days ago, 300 divided by the wavelength equals the frequency. So 300 divided by 6 equals 50 megahertz. So that's the frequency you're going to use in that equation. So 468 divided by 50 is a little over 9 feet, but that's feet, and they ask you in inches. So you have to multiply it by 12, and you get 112.32. And there's your answer right there, 112. And I'm not sure why this 1 meter equals 39 inches is of importance. John, can you comment on that?
Because it says it's a 6 meter dipole,
Okay, so
half
you
wave
can get,
dipole. So half wavelength would be 3 meters. And so that's why you can.
okay, got it. I do it the way that I described, and it makes more sense to me that way. Okay, which of the following increases the resonant frequency of a dipole antenna? Shorten it. So does that make sense, thinking about the swing again, or thinking about a guitar string or a string that you're gonna flick and make it vibrate? The shorter the string, the faster it vibrates. So shorten it is the answer. Here's another calculation. This one doesn't have quite as many twists and turns. What is the approximate length in inches of a quarter wave vertical antenna for 146 megahertz? So again, the formula now is 234 divided by the frequency in megahertz equals the length in feet. So the length equals 234 over 146, which equals 1.6 feet, and you have to multiply that by 12, which gives you 19 inches. And if you think about, if you've seen a mag mount antenna, they are usually about, well, many of them are about 19 inches long. Which of the following types of antenna offers the greatest gain? So they're asking about a directional antenna, and you know that the Yagi is a directional antenna. What is a beam antenna? No, it is not an antenna built from I-beams, nor did Clarence beam have anything to do with it. A beam antenna is the same as a directional antenna. It concentrates signals in one direction. So a Yagi is a beam antenna. Okay, so how could you use an antenna to locate a source of noise interference or jamming? Sorry, methods. And the answer to that is radio direction finding, which makes sense given the project you're trying to do. And another fun thing that hams do, although I've never done it, is to do a hidden transmitter hunt, where somebody puts a transmitter someplace and you have to go find it with radio means. And what you're going to do for that is you're going to use a directional antenna. You can get little Yagis that you can carry around. So that's what you would use for a hidden transmitter hunt. Okay, what is antenna gain? And the answer is an increase in signal strength in a specified direction compared to a reference antenna. So when you are shopping for antennas, you'll see the gain specified on the antenna. This one, I think you just have to memorize. What antenna polarization is normally used For long distance, weak signal, CW or Morse code, and SSB or single sideband contacts using the VHF and UHF bands. And the answer is horizontal. What happens when opposite ends of a VHF or UHF line of sight radio link are not using the same polarization? And the answer is the received signal strength is reduced. It could be reduced to 0, actually. If you think about two antennas on opposite ends of the contact at right angles to each other, nobody's going to hear anything. What is an advantage of a 5/8 wavelength whip antenna for VHF or UHF mobile service? Whip antenna is just another name for vertical antenna. And the answer is it has a lower radiation angle and more gain than a quarter wavelength antenna. However, if you are communicating through a repeater, repeaters are going to be high. And so a lower radiation angle is not necessarily going to be to your advantage. Which of the following describes a type of antenna loading? Inserting an inductor in the radiating portion of the antenna to make it electrically longer. So again, sometimes in a vertical antenna, you'll see it with a little coil part of the wire part way up or down the antenna, and that is a way to make it electrically longer, which means that it's going to be resonant at a longer wavelength. All right, now you're using a directional antenna and you're trying to hit a repeater, but there are buildings or obstructions that block the direct line of sight path. And how can you do that? You can try to find a path that reflects signals to the repeater. This seems difficult to me, but we live in a place where our obstructions tend not to be built, but rather natural. And none of these other answers make any sense. Okay, that is that part. I'm going to stop sharing for just a minute. Any questions about that piece? Remember, this information is, the purpose of this information for you is to pass the exam. Steve, did you have your hand up?
Yeah, I'm just curious about the 5/8 wavelength as opposed to why not a half? I mean, it's sort of, is that just history or something?
I don't know the answer to that. John, do you?
Yeah, it has to do with something you'll find out in the next section, is that the impedance of most transmitters want to see 50 ohms as the impedance, and it just so happens that a quarter wave is about 50 ohms, and that a 5/8 wave is typically about 50 ohms as well. And a half wave is more. I can't remember what the number is for
72 or something, I feel
yeah,
like.
so it's a thing about matching the
Okay.
antenna to the transmitter.
So I mean, it's for a real purpose. That's good.
Yeah, not
Yeah.
just the error. Any other questions? All right, let's see if I can get the share screen back to the right one. Is that the right one?
Yep.
Okay. Now we're going to talk about feed lines, which is how do you get the power that you're transmitting from your radio into the antenna. So here's a very basic diagram. In fact, you could leave out this middle rectangle. The transmitter to the antenna is the feed line or the transmission line. And what most of us use for feed lines is coaxial cable. It's called coaxial because the feed line down the middle and the shield around the dielectric is they share the same axis, so they're concentric. The good things about coax, it's easy to work with. You have lots of different options of sizes and details of construction. The cons are that they are higher loss, so you're losing your energy as you go along the length of the coax. And also moisture intrusion can be a real problem and also increase loss. Here's an important concept. SWR stands for standing wave ratio. And what that is the ratio of the power that is going to the antenna, the power forward, and the power being reflected back. And it's reflected back because of an impedance mismatch. And an SWR meter can show you what your standing wave ratio is. Everybody's happy when the SWR is 1-to-1. So this is a situation where your transmitter impedance is 50 ohms and your feed line and antenna impedance also want 50 ohms. And so your standing wave ratio meter will show you 1-to-1, which is good. And modern transmitters start reducing the power when they see a 2-to-1 SWR, because you don't want to burn out your transmitter by having too high of an SWR. And if you see 4-to-1, that is a complete mismatch. You can measure this with either a directional watt meter or a SWR meter. And you put that obviously between the transmitter and the antenna. So here's questions. What is standing wave ratio? And it's a measure of how well a load is matched to a transmission line. Which of the following should be considered when selecting an accessory SWR meter? And the answer is the frequency and power level at which the measurements will be made. So when you're looking for a meter, you'll see what it's for. Is it for VHF, UHF? Is it for 40 meters or HF? Why is coaxial cable the most common feed line selected for amateur radio antenna systems? Because it's easy to use and requires few special considerations when being installed. It definitely does not have less loss. It has plenty of loss. What is the most common impedance of the coaxial cable used in amateur radio? And the answer is 50 ohms. Now, this is an interesting one. What happens as the frequency of a signal in coaxial cable is increased? And the answer is the loss increases, which means that if you are using UHF with coaxial cable, you're going to have quite a bit of loss compared to VHF or HF. There are various kinds of connectors that are used on coax. And one of them is called a PL259. They are common, they are big. I wanted to put a picture in here, but I didn't have a chance. And the answer to this, they are commonly used at HF frequencies. And this is, again, just one that you have to memorize. For high frequencies above 400 megahertz, so in the UHF range, which of the following connectors is most suitable for those frequencies? And the answer is type N. Answer A is highly misleading and distracting. The PL259 that I just was talking about and its other half, the SO239, is sometimes also called a UHF connector, but that was from a holdover from the old days when HF was somehow called UHF. So don't pick that one, pick type N. There's also a kind of coaxial cable that has as its dielectric air instead of something physical. And its advantage is that, its disadvantage is that it requires special techniques to prevent water from coming in. Which of the following causes failure of coaxial cables? Moisture. Which of the following is a source of loss in coax? Water intrusion, high SWR, multiple connectors in the line, all can cause loss. Why should the outer jacket of coaxial cable be resistant to UV light? Because UV light can damage the jacket and let water in. All right, what is the electrical difference between RG58 and RG213 coaxial cable? And the answer to this depends on you knowing that RG213 is larger in diameter than RG58. And therefore it has less loss at a given frequency. Which of the following types of feed line has the lowest loss at VHF and UHF? And the answer is air insulated hard line. This is the kind of feed line that we're using in the new Neoconi repeater, which they may be putting up right now, or at least be on their way up to the mountain. So
I saw Bill leave his house this morning about 8 o'clock, so that's when I got started.
Okay, great. Okay, which of the following is used to determine if an antenna is resonant at the desired operating frequency? And as you might guess, it's an antenna analyzer. It's the only answer that has the word antenna in it at all, so that's a clue. What's a dummy load? So a dummy load is a non-inductive resistor mounted on a heat sink. And this basically is used, I thought we may have a slide of this coming up, is basically used if you want to test something in your system without broadcasting anything out into the world. Where should a RF power meter be installed? So what you're trying to measure is how much RF power are you radiating? And so the answer to this is in the feed line between your transmitter, which is doing the transmitting, and the antenna, which is going to radiate it. And the power you need to see is how much power is going from your transmitter to your antenna. So therefore, that's where it needs to go. What is a benefit of low SWR? Reduced signal loss. What reading on an SWR meter indicates a perfect impedance match between the antenna and the feed line? 1-to-1. What does an SWR reading of 4-to-1 indicate? Bad mismatch. What can cause erratic changes in SWR? And the answer is a loose connection. Which instrument can be used to determine SWR? Directional watt meter, not an iambic pentameter or even an iambic pentameter, which is my favorite wrong answer in the whole thing, I think. But the answer is D, directional watt meter. Why do most solid-state amateur radio transmitters reduce output power as the SWR increases? And it's to protect the transistors in the output amplifier. You don't want a bunch of power coming back in and frying your transistors. What happens to the power that's lost in a feed line? Like most other things, it's converted into heat. What is the major function of an antenna tuner, sometimes also called an antenna coupler? The function is that it matches the antenna system impedance to the transceiver's output impedance by a series of electrical tricks. It doesn't really tune your antenna in reality. What is the primary purpose of a dummy load? Here's that question I was looking for earlier. And the answer to that one is to prevent transmitting signals over the air when you're making tests. This is a picture of one kind of a dummy load. It has a resistive load and a heat sink that absorb the RF from your transmitter and prevents it from radiating a signal into the environment. Notice that dummy loads can get hot. That's why they have a heat sink. What is the function of the SSB/CWFM switch on a VHF power amplifier? This answer to this question is a memorized one, I think. Set the amplifier for the proper operation in the selected mode. That is it, folks. So let me stop sharing and ask if you have any questions about that piece. You'll find that some of the things like the connectors, questions about connectors and stuff, once you get into actually doing stuff, you will need to know more about that. Here's a, I can get it untangled. Here's a PL259 connector. This looks sort of familiar. It goes into an SO239, and it's a kind of connector. So any questions? Okay, John, over to you.
All righty. Well, like to think that they saved the best for last of these things. Let me share here.
You're the best, John. We definitely agree.
No, not me, the topic. So they want to make sure that you're the FCC wants to make sure that they have a good cadre of available hams. So they'd rather that we didn't kill ourselves in the process of the hobby. So this last section is talking about safety things. And when I was in college, I worked for a summer job for the power company, and we were installing a substation, one of these, things that you see kind of fenced in and with all the wires coming into them and all this equipment out in gravel. And we had a thing that whenever so we were installing new equipment. And so it was like, well, it's not supposed to be powered yet, since we're just turning this thing on. But there's a rule on the power guys that if your supervisor says, change this connection or put this connection in, that you can say, you touch it first. So and you'd see experienced guys do that all the time, where it was a culture that, like, well, if you're telling me to do this, you touch it first. And I was a newbie, and so I was doing the same thing all the time. But there's no supervisor around usually your ham shack, so it's kind of up to you to do it. So it's a pretty safe hobby. There's basically just a few ways to get hurt or killed. And you can electrocute yourself, which would be unfortunate. You can fall off a tower or have somebody up on a tower or something fall on you. Or you can cook yourself with RF energy. So those are the kind of three basic things. And so we basically, let's not do any of those as part of our hobby or part of our emergency response. So you can, people have been killed with as little as 30 volts. And I think most, well, I don't know, but it'd be interesting to know if people take those 9-volt batteries that you have in your fire alarms and stuff like that. And as a kid, I remember I was like, put those on your tongue. And we'd always dare each other to do that. And you can feel a little bit of current usually on those 9-volt batteries. They're not going to kill you or anything, but 30 volts can do it. And very little current can be 100 milliamps can be fatal if it's going through the right part of your body. AC is more dangerous than DC because it can interfere with heart rhythm, but they're both lethal. And of course, the path that the current takes through your body is really important. So the rule of thumb here is always keep, if you're working near dangerous voltages, always keep one hand in your pocket. Because that way, one of the worst things you can do is have a path that's across your chest from one hand to the other. And it could, because your heart's in there, and that's particularly susceptible to other current interference. So even as hard as it might be to work with one hand in your pocket, it's a good idea to do that. And then ground everything. This isn't an issue when you've got your handheld radio because there's really no grounding involved. But if you get to the point where you've got some HF equipment or even VHF base station equipment, it's a good idea to ground things. So you've got your like power strip where you plug into things. Of course, that should be grounded to the house system. And then you have separate grounds between your different ham equipment, that they're connected to a separate ground and a separate ground rod in there. So you and you use nice big flat strap braiding to make the ground connections. So you want to ground all those equipment cases like in the previous slide. Make sure the power outlets are grounded. Boy, we lived in an old house, 1920s house in Portland, and it had gone through many renovations, and there were lots of power supplies that were not power outlets that were not grounded. Yes, Bill.
I've got a question that has bothered me where I live. What do you do if you have solid rock under you and you can't put the ground 6 to 8 feet down?
That's a good question. I think we have an electrician in the audience. Maybe they can. Was that Roy? Or was
I'd put a ground ring in. I'd run number 4 or larger bare conductor around your house and go as deep as you can if you're on solid rock. If you can go down at least 2 feet, you can lay a ground rod horizontal in the ditch. It's the same, or code compliant anyway.
And how long would that ground rod have to be horizontal?
8 feet. And if it's for your house, you still have to do 2 of them with 6 feet in between the top of one. And so if you lay them side by side, there's got to be 8 feet separating this end and that end. And then you put a ground rod here and then a ground rod here and then off to your house. And it has to be a minimum number 4 bare copper.
great.
Okay.
Thanks, Artie. That's very helpful.
Or just call Artie. He'll come.
Okay. The other thing is if a lot of equipment that especially like amplifiers and things like that that have some high power things, they have safety interlocks on doors to get in, on areas to get into the equipment, and you don't want to defeat those safety interlocks. And remember that capacitors store charge for a really long time. When I first got my license, I had a transmitter that had an old tube transmitter that had a 750 volts on the tube, the final amplifier tube. And we had this nice linoleum tile floor, and I had an office chair, an old office chair, and I didn't discharge the capacitor in the final when I turned everything off, and I happened to touch that 750 volts, and it made me my legs jerk, and I ended up on the other end of the basement, because I'd slid all the way across the basement. And I have had good respect for discharge capacitors. So you learn by surviving in this case. So you really do need to discharge them with a screwdriver or something before you work on them. Okay. Antenna safety. Well, there's another place where you can get hurt, is don't put them where they can fall across power lines. So one of the things that you'll probably as a tech, what you want to do is you might want to put up a little outside antenna, and you got to make sure that if you put it up, it's not going to fall across power lines, even if they're insulated, like the insulated lines coming into your house. You definitely don't want to have anything fall on the big power lines, but the little ones also. Don't climb towers without a safety belt, and don't do tower work without a ground crew. So basically, don't do it on your own. And if you're working on a tower, always have a hard hat. This tower behind me here, that was a tower at the station that we had in college. So it's a 150-foot tower, and we put antennas up on the top of that thing. If you look real close, blow it way up, you can see there's some antennas way up at the top there. And everybody that worked on that stuff had their hard hats on, and the guys up there were working on the towers, they drop things, and you hear it hitting the ground, and you go, oh, okay. Don't want that to land on people. And then lightning. Thankfully, it's not a huge problem around here, not like in the Midwest, but basically you ground your antennas when you're not using them. There's antenna switches that have an automatic ground on them that you can just turn the switch off, and that will ground the antenna. And if you have a tower, you ground it, and it has long ground rods, just like your house you'd have for your house. And you disconnect your AC mains during the storms and use line conditioners or surge suppressors. When I was growing up in the Midwest, you had to do all that kind of stuff. And basically, you get off the air during the storm as best you can. I saw some of the hams taking videos of in Florida during Ian, and boy, there were some big lightning things, and the towers and antennas flopping all around, and it's some impressive video. So this is what your AC outlet should look like at home. There should be kind of the green ground wire all the time, and then you have hot and neutral for the two, and they're usually color coded. Black is hot, white's neutral. So this is kind of stuff that's on the exam here. They should look like that. And so what's a good way to guard against electrical shock at your station? Use 3-wire cords and plugs. Connect all AC to a safety ground. Have it protected by a ground fault interrupter circuit breaker. And so all of those are correct. So in the United States, what circuit does the black wire indicate? So that's your hot. If you go back to that diagram, it was black was labeled hot. That's your hot stuff. Where should the fuse or circuit breaker be installed? And that's on that hot conductor. So so there's two questions about hot. So that's where you want to focus your memory on for this. What's the purpose of a fuse? So that's to interrupt power in case of an overload. So there's a couple of fuse questions you might get, and it's always, to protect against overload or heat. I forget what the other question used, but it's interrupt the power. And why should a 5-amp fuse never be replaced with a 20-amp fuse? Well, Excessive current could result in a fire, so don't always have a bunch of different spare fuses of potential sizes, so you can replace them with one that's you're supposed to be. So maybe you could put a 2 amp fuse or a 3 amp fuse in that spot, but you don't want to put anything bigger than the 5 in there. What hazard exists in a power supply immediately after turning it off? Charge stored in filter capacitors. Those darn capacitors, they can bite you. What health hazard is present by electrical current flowing through the body? Well, all of those are candidates. Your tissue can heat up, which isn't a good thing. It disrupts electrical functions in the cells. Not good. And it can cause involuntary muscle contractions, like sending you across the linoleum floor. So what hazard is caused by charging or discharging a battery too quickly? Well, batteries can overheat and kind of cause fires if you're not careful. So you don't want to discharge or charge a battery too quickly. What should be done to all external ground rods or earth connections? So as Artie was saying, you bond them together with heavy wire or conductive strap. So you want all the grounds to be at the same potential. Which of the following is a safety hazard with a 12-volt storage battery? So the voltage of itself isn't enough to hurt you usually with only 12 volts. But if you short the terminals together, there can be a lot of current there, and it can cause fire, or burns and fire and explosion of the battery because it's discharging too quickly. So those are the things that storage batteries can get you with. Which of the following is an important safety precaution to observe when putting up an antenna tower? So you look for stay clear of any overhead electrical wires. You might be, tempted on some of these other ones, but wearing a ground strap wouldn't be a good thing when you're climbing a tower. And insulating the base is the opposite of what you want to do. You want to ground everything. So what's the minimum safe distance from a power line to allow for installing an antenna? And this is that if the antenna falls over, you don't want any part of it to get closer than 10 feet to the power lines. Right, so and even 10 feet is maybe a little too close for comfort. So you just want, when it falls over, you don't want it to be anywhere near a power line. Why should you avoid attaching an antenna to a utility pole? Man, those utility poles are sure attractive things to connect an antenna to. Oh my goodness. They're nice and high and in the clear, and it would be really good. But nope, that's way too close for the antenna. Because, your antenna might fall and contact the power line, which would be a bad thing. But power lines fall, and you don't want them falling on your antenna because that would be a bad thing. So you want to keep those things far apart. What is required when climbing an antenna tower? Well, you need to have sufficient training to do that. One of the guys installing the antenna up or the repeater up there at the site today what the big thing was, getting a qualified tower climber up there to install the antenna. So there's not a lot of those guys around. So they're a pretty specialized thing. And if you saw how many antennas are up there and stuff, trying to fit our little antenna amongst all these other things is going to be quite a job. So having sufficient training is important. And you want to use a tie off at all times, and a safety belt, and a climbing harness. So all those are important things. What circumstances is it safe to climb a tower without a helper or observer? This one's easy. Never ever do that. And what's a good practice when installing ground wires to a tower for lightning protection? You want to make sure that any kind of ground things should be as short and direct as possible. Here's a real, this question has persisted through many generations of this test, and it's just, you got to kind of memorize it. What is the purpose of a safety wire through a turnbuckle detention guidelines? And because a lot of towers used to, or some still do, have guy wires to help stabilize them. And so you have to have turnbuckles to have them tight, but you want to have a safety wire through that, so that through the turnbuckle, so that they don't loosen themselves up. So prevent loosening of the turnbuckle by vibration in the wind. The wind would make the wires kind of vibrate. It's not a good thing. Which of the following is important safety rule to remember when using a crank-up tower? So a lot of towers are freestanding, which means they're just, structures, and they don't adjust, but it's really popular to have a crank-up tower. So you have nested sections, and you can crank up the tower to its full height when you want to, or you can lower it down, like to work on your antennas or something, so you don't have to climb up so high. And one of the safety things on the tower is crank-up towers is you don't want to just climb up a fully extended crank-up tower, because if it decides to uncrank itself and you're up there, that's a really bad thing. They're not made to be climbed when they're extended. So the best thing is to retract them, to take them all the way down to the bottom. And there are some mechanical safety locks that you could put on there, but most guys that I know with crank-up towers just bring them all the way down. So some of the towers, they crank up and down, and then they also tilt over. So you can crank the tower down and tilt over, and then you can get to your antennas real easy without actually climbing on anything. Which of the following establishes grounding requirements for an amateur radio antenna, tower or antenna? And this one's interesting, because you would normally think, well, the FCC is concerned with all this stuff, but that's not the case. It's electrical codes that give the requirements for grounding things. What's considered to be proper grounding method for a tower? And this is 8-foot-long ground rods for each tower leg. Most towers have at least 3 legs, so you would have 3 ground rods, and that they're bonded to the tower and to each other, so they're connected with a strap. So what's the following conductors preferred for bonding at RF? And that's you use flat cable strap, copper strap. Which of the following is true when installing grounding conductors for use for lightning protection? So if you have an external antenna, it's recommended that you have lightning protection, use a lightning arrestor in there, and sharp bends must be avoided when you doing grounding conductors, because if you have a ground wire and it has a sharp bend in it and it's lightning, the lightning can actually it wants to go straight, right? So it can kind of not go the bend, not do the corner, and just go straight to something else. And so you want to have you always want to have curves, nice smooth curves to help the lightning along. So sharp bends must be avoided. And where should you install this lightning arrestor? In your coax feed line. And it's basically near where the feed lines enter the building with a grounding panel. So those are the kind of mechanical things and electrical AC parts of it. There's also RF safety. So because we're dealing with RF fields, it's that can cause problems. And so this is a section that talks about RF, radio frequency safety. And there's two types of RF. One, there's ionizing and non-ionizing. And the ionizing ones are things like gamma rays and X-rays and things like that. And there's a reason why they don't want you to have lots of X-rays, medical people, because ionization can cause changes to your molecules in your body and your DNA and stuff. So it's ionizing is not good for the body. And then there's non-ionizing, which is radio waves, is non-ionizing, and they cause problems because it's like microwave, like your microwave oven. They cause heating of your tissues, and that can cause burns. So non-ionizing radio waves can cause burns, and there's a lot of that. There's various ways of asking that question in the exam. So as I said, it works like your RF heating from non-ionizing works like your microwave. And you don't want to ever touch your antenna or RF source when you're transmitting, because it can definitely burn you, especially if there's very much power involved. And most of us hams have had experience with getting RF burns and some, especially with higher power stuff, and it's not pleasant. Now the FCC has regulations about all this stuff, and they define two different environments. One is a controlled environment, where that's basically in our house and property is we're considered to be aware of RF risks, and we have control over whether we're transmitting or not. So it's a controlled environment. And then there's uncontrolled environments, which is like your neighbors, and they're not aware of RF risks, and they don't have any control over your transmitter. So there's these two environments that have different sets of rules for the within the FCC regs, and it's all about exposure time. Is that if how long you're standing or exposed to this RF energy, and it's kind of the average time that if you're standing by an antenna and it's transmitting all the time, say you're in a controlled environment, the exposure, the regulations are set for like 6 minutes. So how much exposure do you get in 6 minutes? And versus your neighbors in your uncontrolled environment, how much exposure did they get over 30 minutes? Right, so those are the two figures or times that the different averaging is done over. So, I mean, this all sounds kind of technical and serious stuff. And there's basically 3 ways of checking if you have RF issues around your, what the exposure is around your environment. And you can measure the RF fields. So chances are that's it requires equipment that you don't have. And then you can calculate the RF fields, which requires some software. Usually you probably don't have the expertise to do that. And then you can use charts published by the FCC. And these charts are free and they're pretty easy to use. So you have those, you can have those 3 things. So for most people, it's use the FCC charts, but they ask a question and it's got all 3 things in it. So basically, you should install your antenna away from people, especially your neighbors. Higher is better. You just don't want to have antennas close by, especially running a lot of power. And make sure your antenna is not near, it could fall on a power line, and keep your hands and body parts away from feed lines when you're transmitting. So there's some exemptions in the regulations. And so all this stuff doesn't apply to mobile equipment. So anything you can put in your car, it doesn't apply to handheld radios and any station that produces less than 50 watts. So most of the stuff that you're going to run into as a technician license with emergency communication stuff is exempt. So you don't have to worry about it. So what factors affect the RF exposure of people near an amateur antenna? So it's basically all of these. So the frequency and the power level, some frequencies are more dangerous than others. And of course, the higher the power, the more danger. Distance from the antenna, the further you are away, the better. And the radiation pattern of the antenna. If it's a beam antenna, a Yagi antenna or something, and it's directing all of its energy in one direction, you're less exposed if you're standing behind it because it's directing all its energy out there. So basically all these choices are correct. And why do exposure limits vary with frequency? Well, that's the human body absorbs RF energy at some frequencies compared to others. So you don't have to worry about it at some frequencies, and other frequencies you do. Just like if it was microwave, you'd really need to worry about the microwave stuff, and the HF things you have less to worry about. At which the following frequencies does the maximum permissible exposure limit have the lowest value? So this maximum permissible exposure is they say the FCC has regulations that say these are the limits that you should have. The maximum exposure for the different cases. And because it changes via frequency, it just so happens that the lowest value is 50 megahertz. So that's the lowest value. Everything else is higher there. So if you want to minimize the exposure, you can operate on 6 meters, 50 megahertz. That's the best case. How does the allowable power density for RF safety change if the duty cycle changes from 100% to 50%? So that means you're transmitting 100% of the time, and then you go down to 50% of the time. Well, that's the allowable power density goes up by 2 because you've cut the exposure in half, going from 100% to 50%. So that means you can do it for twice as long, basically. So it's factored by a factor of 2. And what type of radiation are radio signals? Right, so that's the ionizing, non-ionizing question. So it's non-ionizing. What are the following acceptable method to determine if your station complies with the RF exposure regulations? So these are the 3 cases. You can calculate it. You can, which is the FCC bulletin thing. That's the easiest way. Computer modeling, that's expensive, and measuring it with equipment, that's expensive too. So, but they're all good. And and just for reference, I've been a ham a long time, and I've never looked at this. So this bulletin, you can, but I don't run anything over 100 watts usually, so it hasn't been an issue. Which of the following actions can reduce exposure? Well, you can relocate the antennas. In other words, get them further away from people. Relocating the transmitter, that doesn't really help exposure too much. And increase the duty cycle, well, that's the wrong direction. So all of them is not correct. How to make sure your station stays in compliance? Well, you just have to, whenever you change out something, you're supposed to check and make sure that you are still meeting the requirements. What's the definition of duty cycle during the average time for RF exposure? So basically, this is the duty cycle means what's the percentage of time the transmitter's transmitting. So 100% duty cycle means the transmitter's on all the time. 50% duty cycle means it's on half the time, for example. How does RF radiation differ from ionizing radiation? The RF radiation doesn't have sufficient energy to cause chemical changes in the cells and damage DNA. Thank goodness. But it's still dangerous. Who's responsible for ensuring that no person is exposed to RF energy above the FCC exposure limits? Well, guess who that is? The station licensee. Why is duty cycle one of the factors used to determine safe exposure levels? Well, it affects the average exposure of people to radiation. It's kind of a weird question, but it's the average exposure that's the important thing. So how long you're exposed is important because it's heating. Remember that RF radiation heats you up. So if you the longer you put yourself in your microwave oven, the worse you're gonna heat up, basically. What hazard is created by touching an antenna during a transmission? Well, you can get an RF burn to the skin. Keep calm because we're all done. You have suffered through 411 questions in the question pool. That's yay. Congratulations. Any questions on that safety stuff? Oh, Bill, you got your hand up still?
Yeah, actually, it's a new question. Back in the 70s, when I was working in the lab and had the radio on, there was a story, I think, coming out of Great Britain about a new home heating system that used low-level microwave radiation in the walls. And so they gently warned you.
Yeah, that sounds like a great idea. I'm glad that that didn't take off. Let's see. Shall we take just a quick 15 minutes break? I know my coffee cup needs to be refilled, and then we'll come in and do some do practice exam.
John, you said 15. Did you mean 5?
15. I meant 5. Yes. Thank you. So it's like 10:23. We'll be back.
John,
Yes.
thanks very much.
Okay, Carl.
I'm going to sign off now.
All righty. Well, happy to have you on in the class, and hope to hear you on the air some more.
I really appreciate you doing it. Excuse me? Thank you.
But we'll see you on the weekly net.
All right. Thank you.
Righty. Bye.
Bruce Maxwell just texted that they're on the mountain.
Oh, he did.
Mhm.
We probably can't see them up there today.
No, I drove by the beach yesterday afternoon and I couldn't see the ocean
Yeah.
at all.
Well, Susan just told me that there's, the fire department is burning down one of the old houses on Lanita. And, she showed me some pictures and there's all this smoke and you can hardly tell smoke versus fog. It's,
Yeah, I had 3 places I could have been this morning. I could have been up on the mountain, but not really. I could have been down there helping with the Burn to Learn, or I could have been here. And frankly, this is a lot more comfortable than either of the other 2. Yeah, it's that old blue house.
yeah, yeah. I'd heard a rumor that there's a brewery going in there,
Oh, really?
in that location.
Oh, interesting.
Yeah, I think it's Steeplejack Brewing. But
How
I
about
don't,
that?
I don't know for sure. It'd be
Hopefully
certainly
it'll be
good to have
hope-
one.
hopefully it'll be better than the winery.
Boy, they certainly are popular, though.
But their wine is not good.
Oh, I didn't know.
It's a great place. I mean, it's fun to go and be there and stuff.
Yeah, it's a very inviting setup they've got.
Could try showing you the picture that Bruce texted. Can you see that?
Oh, yeah, yeah,
So that black shelf is
yeah,
what our
Maybe
repeater is
yeah.
on.
Why don't you text it to me and I can share it?
Oh, great. Okay. You mean you didn't get
Margaret.
one from him? I will text it.
No, I didn't see it.
Margaret, you were showing the PL connector cable first. I was just going to show everybody there's an adapter
Oh, yeah.
to hook the external antenna to my portable radio.
Yeah. The whole connector adapter thing is when I first was studying for the technician exam, it was like, why do I need to know all this stuff? And then when I got radios, it's like, oh, that's why I
Nothing
wanted
fits.
to know this stuff.
You can never have enough adapters.
No.
So let's see. Looks like just about everybody's back. So let's how about we try an exam, see if we pass. So what I'm going to do is share let's see. Hang on a second. Stop. And close it. Right, just so people can see what a repeater looks like. So that's this black thing, and this big black thing is the new repeater up there on the mountain. So it's missing some stuff. It doesn't have its batteries and all that stuff on it, but that's what a repeater looks like up in the flesh. So
It's got this is the black part is basically a rack for the different components, and the battery goes on the bottom shelf. And I'm not sure, but it's possible that very black box to the right and toward the back is the battery.
oh, this thing down here.
Yeah.
Yeah, so that's the battery down there. But there's a bunch of equipment that's not mounted yet. They probably had to take it all off because it's heavy. to carry around.
Hey, John?
Yeah.
So when, is that repeater solely for your yellow radio system?
No, it's for, I mean, it's a general purpose repeater.
Okay, and when it has all the batteries in it, how much time does it have for backup in the event of a full power outage? Do you know?
Well, the site up there has a generator, propane powered generator. And I'm not quite sure what the duration is. There's a lot of equipment that share the generator up there, but my impression was it was 3 or 4 days.
Now,
And the battery is a 100 amp hour, I believe, or 200 amp hour. I think it's 200.
200, yeah.
Yeah.
That's up by the water towers in Manzanita.
No,
No,
this
this
one is up on Neocani,
is up
up
on
a-
top of Neocani.
bumpy road.
So it's got, so this repeater will allow us to talk up into Clatsop County, down into Lincoln County, and maybe somewhat into the towards the east. But there's a bunch of other mountains in the way to get to like Portland, for instance.
Where's the 119 repeater? Is it up there too?
No, it's at the water tower in Manzanita.
So is the Manzanita ham repeater is up at the water tower, which is way easier to get to.
Yeah. Okay, so let's take that's the one I want. So everybody should be seeing the ham study. And we're going to do the technician. And we don't need the app. And so let's take a practice test. So this is exactly what it would, the background's a little different, but this is kind of exactly what you'd see when you take the virtual exam. The same kind of idea. So what is the electrical term for force that causes electron flow? So the way to do this is we'll kind of run through them. I'll give you time to write down your answer, or at least make a mental note of it. And then if you could keep track of which ones you get, how many you get right, that would be, or wrong, either way, that will tell you how you did. So electrical term for force. Okay, so electromotive force. So I'd say that's voltage. What is the relationship between electric and magnetic fields in electromagnetic waves? Right angles. They revolve in opposite directions. They travel at different speeds, or they are parallel. Well, they're right angles. How many milliamps years in 1.5 amperes? Okay, so we're going from big to little. So big to little means that we go to the right. So 3, right? 3. So 1, 2, 1, 2, 3. So it's going to be 1500. Which of the following methods is used to locate sources of noise interference or jamming? So echolocation, that's what bats do. Radio direction finding, Doppler radar, phase locking. I don't know what phase locking is. So radio direction finding. What's the function of a transceiver's PTT input? So PTT is push to talk. So switches from receive to transmit, input, preamplifier, input for a key, transmit tones. No, transmit switches from receive to transmit. What's the resistance of a circuit in which a current of 3 amperes flowing when connected to 90 volts? So we want resistance. So think of your little EIR, and we're looking for resistance. So you put your thumb over the R, so it's E divided by I. So 90 divided by 3 is 30. What's the approximate bandwidth of AM fast-scan TV transmissions? Oh, okay, I have this memorized, so it's about 6 megahertz. What reading on an SWR meter indicates a perfect impedance match between the antenna and the feed line? It's 0, full scale, 1-to-1, or 50-50. They all, sound kind of good, but it's one. SWR is always a ratio. It's 1-to-1 or 4-to-1 or something like that. What is a unit of inductance? So we've got ohm. Well, that's resistance. We've got the coulomb. We haven't talked about what that unit is. Henry, oh, could be, and farad. So it's Henry, because capacitance is farad and resistance is ohms. What type of transistor has a gate, drain, and source? So that's the dirty laundry garden, dirty something. I forget what the mnemonic is. Anyhow, it's not Tesla. It's not a varistor. It's going to be one of these two, and it's the field effect. Who may select a desired call sign under the vanity call sign rules? General or extras? Anybody? Just an extra? Or if you've been licensed more than 10 years. So this one's anybody can do it. It didn't used to be the case, but it is now. Which of the following are required for remote control operation? Control operator at the control point. Control operator must indirectly manipulate the controls. All of these choices are correct, or the control operator is required at all times. So this is all these sound pretty good. You have to be at the control point. Manipulate control, so all those correct. What's the characteristic of an HF communication compared with communication on VHF and higher? So HF antennas are smaller, wider bandwidth, less atmospheric interference, long distance ionospheric propagation is far more common. Okay, so HF antennas are big. Doesn't have anything to do with bandwidth. There's more interference on HF. So that one, long distance. HF is long distance. VHF, UHF is short distance. What is a symptom of RF feedback in a transmitter or transceiver? SWR, blowing the power supply fuse. Transmitter will not stay on the desired frequency, or reports of distorted or garbled voice transmission. I'm going to guess this one here. when are you required to transmit your assigned call sign? Okay, so 10 minutes during and at the end, 15 minutes during and at the end, the beginning of every contact, and then 10 minutes or at least once during each transmission. So this is, it's every 10 minutes and at the end. Except for some specific restrictions, what is the maximum peak envelope power output for tech class operators using frequencies above 30 megahertz? So this is there's only 2 power levels you have to worry about, and that's the maximum limit is 1500 watts, or there's cases where it's only 200 watts. So below 30 megahertz, it's 200 watts. Above 30 megahertz, it's 1500 watts. What's the result of tuning an FM receiver above or below a signal's frequency? So you're not tuned directly. So sideband inversion, I don't know what that is. Distortion of the audio, a tone, or a change in audio pitch. So it's this one. The change in audio pitch is if it's sideband, single sideband. What component changes 12 volt, 120 volts AC to a lower voltage? Transformer, diode, transistor, capacitor. So that one's transformer. Transforming the voltage. What hazard exists in a power supply immediately after turning it off? We better have that one memorized. Think of me scooting across the floor. Let's see. So leakage flux, charge stored in capacitors, circulating currents. So charge stored in capacitors. Which of the following battery chemistries is not rechargeable? Lead acid, carbon, zinc, lithium, nickel cadmium. So there's only one here. So the carbon zinc, that's the old style batteries that leak all over your equipment when they get old. What is an ARQ transmission system? Special transmission format limited to video, encrypted command signals to a satellite, error correction, detects errors and sends a request for retransmission, or a method of compressing data for Q codes. It's this one, the error correction. ARQ is advanced. I can't remember. ARQ request, automatic request exchange, basically. Oh, here we go. Got one of these. What is component 4? So it's up here, and it's a delta thing, triangle. So dummy load, no, it's not a ground. It's not a transmitter. It's an antenna. Which of the following measurements are made using a multimeter? Voltage and resistance, signal strength, impedance, reactance. This is the one where it's just voltage and resistance is multimeter. Under what conditions is an amateur station authorized to transmit music using phone emission? Music, when the music is transmitted above that, music produces no spurious emissions incidental to authorized retransmission of manned spacecraft communication, limited to less than 3 minutes an hour. This is the spacecraft one that you can do it if you're retransmitting NASA stuff. What is antenna gain? Additional power required? Additional power that is added? Increase in signal strength in a specified direction? Increase in impedance. So the gain is the increase in signal strength. What type of signaling uses pairs of audio tones? So pairs, this is the subaudible tone one, DTMF dual tone modulating frequency. So this is D for dual. So it's a pair of tones here, and none of those guys. So it's this one. This is unfortunate they got another D here, but it's the dual tone one, DT. Which of the following is true when installing ground conductors for lightning protection? Carefully routed with precise right angle bends. Use only non-insulated wire. Common grounds must be avoided, and sharp bends must be avoided. So you don't want sharp bends. You want to keep lightning on the wire. Which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? Okay, so computer line out to transmitter speaker. Transceiver speaker, excuse me. Computer line out to transceiver push to talk. Computer line in to transceiver speaker, or computer line in to transceiver push to talk. Okay, so it's not push to talk, but it's either the in or the out. So computer line out, so that means the computer's outputting something. So the transceiver speaker connection is the transceiver putting out something. So you don't want to have two out things going together. So computer line in to the transceiver speaker out. So here's an in and an out. So I think that's the right one. But you got to be careful on that one. How can you make sure your station stays in compliance with RF safety regulations? We just talked about that. Make sure your antenna has low SWR, reevaluating the station whenever an item is changed, or informing the FCC of changes made. So it's this guy here. You have to reevaluate. What is the national calling frequency for FM in the 2 meter band? So 2 meters is roughly 145. So it's this one or this one. And this, we just know that this one is the national calling frequency. Which of the following is a way to determine whether your satellite uplink power is neither too high or too low or too high? Listen for distortion. That's a good thing to do. Your signal strength on the downlink is about the same as the beacon, or check signal report in the telemetry data. So this is the case where you're sharing the power, and so you want to make sure that your signal strength is about the same as the beacon. If you're stronger than the beacon, that means you're taking too much. What does the term traffic refer to in net operations? Operation by a mobile or portable station. That could be traffic, like drive too many cars, too many mobiles. Messages exchanged by the net stations, requests to activate the net by a served agency, number of stations checking in. So this is traffic is messages, just another word for messages. What's the major function of an amateur of an antenna tuner, antenna coupler. It matches the antenna impedance to the output impedance, helps the receiver automatically tune in weak stations, allows the antenna to be used for both transmit and receive, automatically selects the proper antenna for the frequency band. All those things are helpful, but antenna tuner matches the antenna to the output impedance. Let's see, did I? Yeah. Okay. What antenna polarization is normally used for long distance UHF or CW and SSB on HF and VHF? So normally, like with your handheld, you want the antenna is vertical. So for FM on UHF and VHF, you want it vertical. For CW and SSB, you want it horizontal. Which of the following is part of the basic and purpose of amateur radio service? Okay, so this was from way back on Monday. Advancing the skills of the technical and communication phases of radio art, providing communication for nonprofits, personal radio communications for as many citizens as possible, and all is correct. So this is the radio art thing. Advancing the skills of regular art. All right, so does anybody we can go back and change any of these that we want? Should we just see how we did? Hey, we got 35 out of 35. We didn't miss any. All right, should we do one more?
And to pass, you have to get 26 correct. All right?
Yes. So before I go, actually, I won't do that. Let's go. Let's close this. And so you can see how we did here. Each of the different sections. All those T's that we went to, the different subtopics, that tells you how you did. And we basically got, you know, how they were distributed and what our aptitude is for it. Let's see, is that a chat that I need to pay attention? Practice test. All right, here we go. Another random selection of questions. What property of a radio wave defines its polarization? Is it the magnetic field, the electric field, the ratio of energy in the magnetic field to the energy in the electric field, and the ratio of velocity? So it's the orientation of one of these two, magnetic or electric, and just by convention, it's the we use the electric field as the one. What hazard is created by touching an antenna during a transmission? Electrocution, burn to the skin, radiation poisoning. This is the RF that burned to the skin. What describes the ability to store energy in an electric field? Okay, so electric field. Capacitance, resistance, tolerance, and inductance. So capacitance is electric, inductance is magnetic. So the wires, remember inductance, it's the wires, the coil of wires, and so that's kind of a magnetic thing. Which of the following is an important safety rule to remember when using a crank-up tower? Must not be climbed unless it is retracted or mechanical safety locks installed. You don't want to ever paint the tower? No, it's not true. It must never be grounded. That's not right. So it's you shouldn't climb it unless it's retracted. Which of the following could be a reason you are unable to access a repeater whose output can be heard? So you've got the offset wrong. Yeah. You have the wrong CTCSS tone. Yeah, that would make it difficult. And you're using the wrong DCS code. Yeah. So I'm guessing it's all are correct. What's the resistance of a circuit in which a current of 3 amps flows through the connected to 90 volts? Oh, this is the same question as the last time. So we cover up the R, and so that it's E over I. So E volts 90 divided by 3 is 30. Why is a coaxial cable the most common feed line for amateur radio systems? Well, Margaret told us that this morning. Less loss, easy to use, less expensive, can handle more power than any other type of line. So that's this one is it's easier to use. What is the characteristic of VHF signals received via auroral backscatter? So now we're transmitting up to the aurora, and it's bouncing off those curtains of aurora. So when you're strongest when you're aimed west, it's received over 10,000 miles, occur only during winter, and distorted and signal strength varies considerably. So this is the right answer here. It's you can just think of the curtain, those flowing things is really going to distort a signal bouncing off that. When under normal conditions may a technician class licensee be the control operator of a station operating in an extra class band segment? As a contest team, using a club station, when designated as a control operator, or no time. So this is you can never operate as a control operator outside of your class license. So no time. So you can operate as a control operator if you stay in your technician class band segments. Which of the following displays an electrical quantity of a numeric value? Transistor, that's a part. Relay, that's a part. Potentiometer, that's the volume control. Variable resistor, meter. So meter is what displays electrical quantity. Which of the following actions should you take if a neighbor tells you your station's transmissions are interfering? Install a harmonic doubler in the output of your transmitter and tune it. Okay. Make sure your station is functioning properly and that it does not cause interference to your own. Immediately turn off your transmitter and contact your FCC office. So this one is you make sure you're transmitting functioning properly and not causing interference to your own station. And then obviously you ought to help your neighbor resolve the resolve the issues. Which of the following self-assigned indicators are acceptable when using phone transmission? Stroke, slash, slant. This is Margaret talked about this. Those are all equivalent things, so all of these are correct. Which is the name of an electrical wiring diagram that uses standard component symbols? Schematic, connector pinout, flow chart, bill of materials. This is the schematic thing. Who may receive telemetry from a space station? Anybody who's registered with AMSAT, with a transmitter equipped for interrogating the satellite, anyone, or a licensed amateur who has been certified by the protocol developer. Well, anybody can receive transmission from a space station. They might not know what to do with it, but anybody can receive it. You don't even have to be a ham. What does the abbreviation FET stand for? Fast electron transistor, frequency emission transmitter, free electron transmitter, or field effect transistor. Well, that's the one we've talked about. Which of the following can damage a multimeter? Not allowing it to warm up properly. Attempting to measure resistance using the voltage setting. Failing to connect to one of the probes to ground. Attempting to measure voltage when using the resistance setting. So let's see, it's going to be this one, measure resistance using the voltage setting, or attempting to measure voltage when the resistance setting. So usually it's, if you're trying to measure voltage, that means it's powered. And if you're on the resistance setting, you don't want things to be powered. So I think this is the right one. What's a beam antenna? Something invented by Clarence Beam. An antenna built from aluminum I-beams. Antenna that reverses the phase of received signals, or antenna that concentrates signals in one direction. So it's D in this case. Which of the following is an application of APRS? So you need to remember what APRS stands for. So APRS is Automatic Position Reporting System. Automatic Position Reporting System. So voice over the internet, automatic number of packets received, real-time tactical digital communications in conjunction with a map showing location of stations. Location, position, location. Providing information, the number of stations assigned into a repeater. So I'd say it's this one because it says position reporting and showing location. Where is an RF preamplifier installed? So this is a preamplifier. So it's output of the transmitter power amplifier, output of the receiver audio, between the transmitter and the receiver, between the antenna and the receiver. So this is a RF preamplifier. So that means it's going to preamplify the signal. So that it goes between the antenna and the receiver. You might get a question that says, where does an RF power amplifier go? And now that goes between the transmitter and the antenna tuner, for instance. But so preamplifiers are on the receiver. When may an amateur station transmit without identifying on the air? Transmit power below 1 watt. Transmitting signals to control model craft. Transmission of brief nature for a station adjustment, or when transmissions are unmodulated. So this is the case where you really have to identify all the time, except when you're controlling model aircraft or sending controlled signals to the spacecraft. What's the advantage of having multiple receive bandwidth choices in a multi-mode receiver? Increases the offset, monitors several modes at once by selecting the appropriate filter, increases the number of frequencies stored in memory, permits noise. Okay. So this is remember all the different modes, CW, sideband, AM, they all have different bandwidths. And so having them, if you want to receive those different bandwidths, it helps to have different filters there. So if you're going to monitor several modes, having a separate filter for each mode is good. Oh, what is equal to 1 million picofarads? Dang. So this is the picofarad thing. So this is the one that is not 3. So we're going from pico to micro. So we're going from little tiny to bigger. So that means we need to go with the decimal point to the left. And in this case, it's the left. So for here, in this case, we go, it's not 3, it's 6. So 1, 2, 3, 4, 5, 6. So it would be 1 microfarad. So this is the picofarad one is the one question that's the exception. And we just lucked out on this test to get that one question. All the other ones are either right 3 or left 3. Which of the following is a disadvantage of FM compared to sideband? FM is harder to tune, voice quality is poorer. Only one signal can be received at a time. So FM is the one where you can only hear one at a time. What information is contained in the preamble of a formal traffic message? Information needed to track it, the email address, the address of the intended recipient, and the telephone number of the addressee. So the preamble is what has all the information you need to track things. So preamble is tracking. What reading on an SWR indicates perfect match between transmitter and sorry. So this is we got this question the first exam. So it's a 1-to-1 ratio, standing wave ratio, 1-to-1. Where should a lightning arrestor be? Oh, it's back on this question. There's only 2 questions that have ratio in them with SWR. One of them is perfect match. It's 1-to-1. And the other question is mismatch, which is 4-to-1. So those are, you only have to remember 1-to-1 and 4-to-1. And 1-to-1 is perfect and mismatch is the 4-to-1. Where should lightning arrestor be installed in a coaxial feed line? Okay, we talked about that at the antenna feed point, near the ground panel, near where the feed lines enter the building, AC panel, output of the connector to the transceiver. So this is a lightning arrestor. So you want to have it direct the lightning away from everything, the ground. So you want lightning to go to ground, not into your house. Which of the following battery chemistries is not rechargeable? Oh, we had this question last time too. Different order though. So lead acid, you can recharge. Lithium ion, you can recharge. Carbon zinc. This is the carbon zinc one. Which of the following is a good electrical insulator? Glass, mercury, copper, aluminum. Oh, glass is the only insulator here. The only non-metallic thing. Which of the following locations may an FCC licensed amateur transmit? Which of the following? So a vessel or craft licensed located in international waters and documented or registered in the United States, anywhere in ITU regions 2 and 3, within any country that is a member of the United Nations, and within any country that belongs to the International Union. This is the one that you have to be in a sovereign US thing. So it's you can be in international waters, but you have to be registered. The craft has to be registered in the US. What's an electronic keyer? A device that assists in manual sending of Morse code. A device voice activated. A device for switching antennas. And the interlock. So this one is the assist in manual in Morse code. So electronic keyer. Think of a Morse code key. What happens when an antenna is at opposite ends of a VHF, UHF line of sight radio link is not using the same polarization? Okay, so this is the vertical polarization, horizontal polarization. What happens when that happens? Nothing significant. It'll have an echo effect. Modulation sidebands might become inverted. A received signal is reduced. Well, that's the received signal is reduced. That's why we tell you to point. The repeater antenna is always vertical. And so if you want to have a good signal into the repeater, you need to hold your handheld with the antenna vertical. Which of the following methods is used to locate a source of noise, interference, or jamming? Oh, we had this question last time too. So it's not BATS, echolocation, or Doppler radar speeding or phase locking. It's radio direction finding. What's meant by the repeater offset? Number of simultaneous transmitter frequencies used by the repeater. Repeater station identification is done on a separate frequency. Repeater has a time delay to prevent interference, or the difference between the repeater's transmit and receive frequencies. So repeater offset is this one, difference between the repeater's transmit and receive frequencies. Which of the following frequency ranges are available for phone operation by technician license? Oh. So these are all 28 megahertz basically. So that means they're all 10 meter ones. Boy, you just have to memorize this one. So I think it's this one, if I remember correctly. We'll see. So it's the 28.3. 28.3 is the one to remember. Who selects frequency coordinator? Local chapter of the National Council of Independent Frequency Coordinators, the FCC regional office, or amateur operators in a local regional area whose stations are eligible for. So hams are, ham radio is largely self-policing and stuff. So the FCC doesn't do much for policing or enforcing things. It relies on on hams to do it themselves. So local or regional area. Katrina, you got a question?
Yeah. Can we go back to, I think it was slide 27 about the lightning arrestor? I got myself confused on that one. I remember you said there was something that you put on top of the antenna.
So
what am I confused with?
On top of the antenna.
Didn't you say there was like something that resists lightning that you, I think I saw your hand do this, where you put it on top of the antenna. In essence, it repels lightning instead of sending the lightning down all the way through the ground. What was that?
No, yeah, no, it was, I think I was trying to, it was about how do you route the wire, do you use short, do you make it
short and direct?
Yeah. Okay. Do you make it nice right angle, or do you make it smooth? And you want the lightning to you want to direct lightning nice and smoothly into ground. That's the idea. And not have it come into the house. So the best place to do that is right at the house where there's a ground connection.
Thank you.
All right, so let's grade it and see how we did here. Oh, we missed one. Let's go see. So I think it will show us. I'll bet you it's that frequency one. What? No. Oh, did I click the wrong thing? What is an advantage of having multiple received bandwidth choices on a multimode transceiver? Permits monitoring of several modes by selecting a different filter for each mode. See what the correct answer is. Permits noise or interference reduction by selecting the same. Oh.
If you click on
Yes.
the little corner thing, it'll explain it.
Yes. So I see where I screwed up here is that the answer that I selected says that permits monitoring of several modes at once. Okay, whereas the correct answer says permits noise or interference reduction by selecting a bandwidth matching the mode. So yes, that was I was going too fast and didn't read the questions completely. So bad on me there, but I still would have got passed. So I only missed one. Okay. Well, let's see if I go back. If I close that. So we're just about done. How about it? I'll stick around if we want to run through some later, but I've got a few more slides to do. Let me. Okay, so you'll be getting your side here. You can, when you take the test and pass, you can get, as soon as you get the email from the FCC saying with your call sign and stuff, you can operate. Or you can look on the database, FCC database, the universal licensing system, and see what if you're licensed or not. So we'd like you to, so two things we'd like you to send an email with when you're going to take the test. So for instance, Diane told us earlier that she was going to take it on Monday. And so let us know when you're going to take it so we can kind of use that to estimate when your license will be issued. And then of course, if you could let us know what your call sign is when you do it. So there's that. And now, what do you want to do with your new license? So we'd like you to support the amateur radio locally with EBCNB. So we can check in on we have the weekly net on Thursdays at 6 p.m., 6:30 p.m. is the ham one. And we occasionally do exercises and things like that off a Thursday night. And it's really good practice to, keep it, even though the check-in is really short and stuff, you get to hear everybody else that's on, and it helps you make sure that your equipment is working and stuff. There's TIERS, which is Tillamook Emergency Amateur Radio Service. They also have a weekly net at 7 o'clock on the Mount Ebo repeater. And the club they used to have a club associated with it, but they don't currently. Maybe it's going to get started back up here. And you can also get involved with community service stuff, like American Red Cross has some ham components too. And there's a national organization called the Amateur Radio Relay League, ARRL, and they're kind of the national advocate group for hams. And so joining the ARRL is a good thing. You get a newsletter and a magazine, and there's a bunch of different there's actually several different magazines, and they advocate for the FCC and for the federal government for stuff. So the ARRL has been around for a long time, since 1914. And they get the QST magazine is got lots of interesting things on it. Margaret?
And for relatively new hams, there's another magazine that you can get instead of QST actually mailed to you, and it's called On the Air. And it only comes out every other month, but it has articles in it that are way more suited to somebody at my level. I mean, I have an extra license, but I understand far more of the articles in the On the Air magazine, and you can always get either of them online, even if you opt to get the On the Air one in the mail. And it's really good. And the other thing I would say is every June, there's a ham fest called CPAC, SEAPAC, which is held in Seaside at the convention center. And it can be pretty fun. They have workshops, they have lectures, they have a whole bunch of exhibits with different companies showing you all their cool new stuff. So that's fun too in June. And maybe by June, COVID will be even less scary.
Yes, Katrina? Thank you, Margaret.
On the Air also has a podcast.
Yes.
Yeah, and so that's free. It's just easy to listen to. I started. It's pretty fun.
Good. Yeah, let me hang on a second while I can get this out of the way here. I've got Zoom in my way. It's ARRL.org is the name of the organization, and you can a lot of this stuff is all available to you just and to the general public. You don't have to be a member. You have to be a member to get the some of the magazines, but it's a great resource to find. Let's see. That's it. Let's see. Is there anything else that I'm missing? Margaret, Bill? Yeah. Did you have another question, Katrina?
Yeah, and maybe this is not just for the group. Maybe this is more specific for me. But what what nets could I belong to out here in Pacific City? I would guess I can't reach you guys. I'm not sure how it works.
Yeah. Do you want to talk about that, Bill? And you're muted. Yep, you're still muted, Bill.
Yeah, so one of the things to look at in the hopefully near future is the Tillamook County Oxcom, which is a emergency radio service that is in the process of getting organized. And it's something that you might want to get involved with, and I can send you information related to that. But among the other things associated with that would be participating in nets like the Tiers net that's been referred to, and also hopefully exercises of various sorts to try things out and see who we can actually talk to.
Yeah, and there's also there's the Mount Ebo repeater that you can probably hit from Pacific City, and probably a lot of Lincoln County repeaters you can hit. I want to share one other thing that's a great resource here. There's a resource that tracks all the different repeaters. It's called repeaterbook.com. And let me log in here. It's free. And I could show you some of look at Oregon. So there are 485 repeaters in Oregon, which there's a lot of repeaters. You can look by band, you can look by feature, you can look, recommended by the nearest highway. You can look at all the repeaters you can hit from I-5, driving down I-5. And if you look in nearest towns and cities, if we go down, we can look by county. So if we look in Tillamook County, so here's all the repeaters in Tillamook County. And here's the Manzanita repeater down here. This is this repeater, the 147.22.22 and up on Mount Ebo. That is the primary emergency response repeater for Tillamook County. So the county has 3 different repeaters: primary, secondary, tertiary repeater, and the 147.22 is the primary repeater. And what's nice about that repeater is that it's a wide regional repeater. It gets over into Salem, and a lot of people in kind of up Portland way, if they have a reasonable antenna, they can get into it. So it's a very good wide area coverage repeater. So this is a good resource. A lot of these, when you get your radio, if we program them, if you get your yellow radio reprogrammed, or maybe the freebie radio, you can put all these in and have access to that. And you can add Lincoln County and Clatsop County. And so there's a resource called the regional frequency template that has, for all Northwest Oregon, has all the different repeaters and stuff that's available. So there's tons and tons of resources on this stuff.
And one thing, maybe just specific to Katrina to comment about, is that we're still in our early stages of setting up networks down here, and having a new contact in Pacific City will be good to see how well we could connect potentially by simplex, and ultimately, hopefully, to link together our GMRS zones. So once you get a radio, we might be calling you up just to see if you want to participate.
Yeah, and the other aspect is since you're down in Pacific City and involved with the CERT stuff, is a lot of the up in North County here, we've got we use the yellow radio, the GMRS yellow radios for communicating amongst neighborhoods and general geographic areas. And then hams are what we use to communicate between shelters and medical facilities and stuff, and with Tillamook County Emergency Management. So the Tillamook County EOC and stuff. So the ham and CERTs, the CERT supervisor is also a ham down or up here. So the CERT would communicate with say the fire department and stuff using ham stuff. So it's there's a CERT component for the hams. So the individual CERT teams would use the GMRS yellow radios, but then the CERT communication with the fire guys, for instance, would use ham. Let's see. So you'll probably get some emails about once, a little bit down the road here, once everybody gets their licenses and stuff, we'll send some more resources around about how to get on and what to do. And we'd really like to hear you on the Weekly Net. We'll introduce you as one of the new hams and stuff. So we'll welcome you to the community. Any final thoughts, Margaret, Bill? Oh, any question, any final send offs?
John, can you remind me, did you send us a link to, is it Herb for the test?
Yes, I did. I think I sent it, let's see. Oh, actually I've got
I think I remember you showing us slides, but I'm not sure if you, and they may be there. I've
got
It's aa7hw.org, right? Is how you get to those guys, right?
say that again.
aa7hw.org.
Yeah, so let me do this here. 7hw.org. So this is the aa7hw.org, the VE team, and these are the remote ham and the remote exam instructions. You can click on about finding an exam and click on the exam schedule, and here's all the off of the hamstudy.org site. So the aa7hw is a good source to kind of start from. I can
Thank you.
I can send that in chat too. If I can figure out where my window went. Everybody. So I sent the link on chat there for. And Herb goes into great detail about all the different things you need to know to take an exam, and the process and stuff. So it's a yeah, Margaret.
Yeah, I just wanted to say that you're also welcome to attend our North County Club meetings. We meet approximately monthly. on the third Monday at 4 o'clock in the afternoon, and we are meeting on Zoom. I don't know how much longer that will last, but that means that those of you who aren't in North Tillamook County can attend as well. And the purpose, so our club is called the Hamsters, which I find charming. And we have educational information, and sometimes we have drills or exercises, but in the winter and during COVID, it's been on Zoom. So you're welcome to join us, and John usually sends out an email beforehand to let you know when and what is happening.
Yep, and I'll, the other point is that you can get to the EVC HAMS website, which I'll put it in the email too, which by going to resources, EVC materials, this is, and then ham radio here. I'll send this link in to everybody. This has got all the different, it's got all sorts of different information about the different North County stuff that's going on. Weekly net, the monthly meetings, past ones and stuff. So Katrina.
Just something basic. I wanted to throw out there that when I registered to take my test, you pay your $14 fee just right on the spot. And I thought, oh goodness, I don't have that app. You pay it through something called SquareSite, and you don't have to install an app. It's just super easy. So just throw that out there, that if you see that, it's just so easy to do.
Okay, good. Thank you for that. Let's see, get out of here. So we've got I've got a follow-up wrap-up email to send, and it's got a lot of these links and stuff in it, so we can hopefully you can save that email and you'll be able to refer to that stuff over time. Well, thanks everybody. It was it's always interesting to teach these guys, and it'd be wonderful to have 10 new hams in the area. And we'll, feel free to, get a hold of either of the three of us to ask questions or anything like that. There's a term in ham radio called Elmers Elmers are your kind of mentor of, experienced hams, and we're happy to serve that role. And so and any questions, we probably know what's going on locally. And
It's a huge thank you, guys, all of you for putting this on for us. Thank you.
Yeah, thanks a lot.
Yes, thank you very much.
okay, you're welcome. And we'll see you all on the air.
Okay, thanks.
Bye. And Bill and Margaret, you stick around. Well, yay. Thank you.
Oh, you're still recording. Just in case you want to say